Everyone, this is Dr. Eti. Now today we are going to explain what is the Rolle's theorem. Here, Rolle states that the function f of x, the function f of x in the interval a comma b, Rolle's what about to say that here first condition means the function f of x is continuous. The function f of x is continuous and derivable. Continuous and derivable. That is f of a equals to f of b. Here the given function f of x in the interval a b. Here f of x satisfies the conditions means f of x continuous and derivable, and then that is f of a equals to f of b. Next that here the any interval, I mean suppose here the interval there exists c belongs to, here the point c, there exists c belongs to a comma b such that f dash of c equals to 0. F dash of c equals to 0. In this here the given function f of x in terms of f of c, derivative of f dash of c equating to 0, and then find out the value of c in between the interval a comma b. Those are three conditions are satisfied. Then this theorem is known as Rolle's theorem. Okay, now here I will be explained one example problem, that is verify Rolle's theorem. Verify Rolle's theorem. Verify Rolle's theorem. The function f of x, the function f of x equals to x minus a whole power m into x minus b whole power n in the interval a comma b. The interval a comma b. Okay, here the given function f of x satisfies Rolle's theorem or not in the interval a comma b. First of all, here write the given function, that is f of x equals to x minus a whole power m into x minus b whole power m n, in the interval a comma b. Here already we know that about Rolle's theorem states that we know that here the given function f of x, the given function f of x is continuous and derivable, is continuous and derivable. That is f of a equals to f of b. Satisfies, verify the given function f of a equals to f of b. Now here the given function f of x, first of all write in terms of a, I mean in place of x have to write a, that is f of a equals to here a minus a whole power m into a minus b whole power n, that equals to 0, and f of b. Now here f of b means in terms of x I have to write b. F of b equals to b minus a whole power m into b minus b whole power n equals to 0. Okay, or therefore f of a equals to f of b. Therefore the given three conditions or the given three conditions are satisfied. Three conditions are satisfied. The given three conditions are satisfied. Now, another condition here, role is, what about to say that the point C belongs to, there exists C belongs to A comma B such that f dash of C equals to 0. F dash of C equals to 0. Okay, yeah. F dash of C equals to 0 means the given function f of x, first of all write in terms of C. F of C, that is C minus A whole power m into C minus B whole power n. Now here f dash of C equals to 0. First of all here find out f dash of C. I mean here f of C is there. Differentiation one time is how to say that here f dash of C. In this function of f of C, here now differentiation one time. Here there are two functions is there. U, assume that U, V. This is U and this is V. Now using differentiation means formulae differentiation of UV. What is the formulae? Differentiation of UV means differentiation of UV equals to U into V dash plus V into U dash, that is U into d by dx of V plus V into d by dx of U. This is the formulae for differentiation of UV, or both are same here, or differentiation of U into differentiation of V plus V into differentiation of U. This is also U into differentiation of V dash plus V into differentiation of U dash. Now differentiating this here using UV formula, first of all here constant, U means constant, here U means C minus A whole power m. First of all here U means constant, then go to differentiation of V. Here C minus V whole power n, differentiation of according to the formula x power n. Here in place of x means C minus B is there. Now x power n formula means n into x power n minus 1. Therefore n into C minus B whole power n minus 1. Next that plus. Here V is the constant. Now plus V is the constant. Here V means C minus B whole power n into, next the differentiation of U, that is m into C minus A whole power m minus 1. Here in these two terms will get to common here C minus A whole power m and C minus B whole power n. Here now we are going to take common means C minus A whole power m and C minus B whole power n into here in this first term C minus A whole power m is common here. Next write n into C minus B whole power n also common here. Therefore write C minus B whole power minus 1. C minus B whole power minus 1 plus, in these two terms here C minus B whole power n means common. Next write m into C minus A whole power m also common here. Next write C minus A whole power minus 1. Okay, next here write f dash of C equals to 0. That implies C minus A whole power m into C minus B whole power n into here n by C minus B plus m by C minus A equals to 0. This is also equals to 0 and this is also equals to 0. Why? Because f dash of C equals to 0. This is f dash of C equals to 0. This is also f dash of C equals to 0. Here f dash of C equals to 0. Here multiplication of C minus A whole power m into C minus B whole power n. After we will get to transpose RHS means 0 by C minus A whole power n, C minus B whole power n, that is 0. Now write n by C minus B plus m by C minus A equals to 0. Now here taking the LCM means C minus B into C minus A. Now multiplying cross multiplication here, n into C minus A plus m into C minus B, m into C minus B equals to 0. Next that, here in this denominator, after we will get to transpose RHS multiplication, that is 0 into C minus B into C minus A means 0. Now here write, that implies n into C minus A plus m into C minus B equals to 0. This is nc minus na plus mc minus mb equals to 0. Here in these two terms we'll take out the common c into here m plus n, c into m plus n plus minus na minus na minus mb equals to 0. Next that here c into m plus n equals to na plus mb, na plus mb. Therefore c equals to na plus mb by m plus n. Okay, this is the c value. Here in the c value, in between a and b, therefore c belongs to a comma b. There exists f dash of c equals to 0. Okay, hence verified Rolle's theorem. Therefore, hence verified Rolle's theorem. Okay, thank you.